All right, so trigonometric substitution, by the title, it almost seems like we're going to be dealing with trig, obviously, right? It's a little confusing, though, to begin with. You actually don't have any trig. So just bear with me. You're going to have problems that do not have any trigonometry at all involved in it. And what we're going to try to do is we're going to bring the idea of trigonometry to try to help us figure out the integral, okay? So here's what you need to understand. This section is going to help us solve, so it's going to help solve the following integrals. And it's going to be three types of integrals. An integral that involves a square root, in which you have a number squared minus u squared. So that u, by the way, will have a variable. So a squared would just be a constant square, right? A number square, and u has to have a variable with it, okay? We will also be able to solve square roots in which you have the addition of the two. And thirdly, we're going to be able to solve integrals that have the square root of some variable squared minus some constant squared. So as you can see, it's just a variation. You either have the constants first and subtract the variable. You either add them together, which, by the way, with addition, it doesn't matter what you have first. Or you have the variable square minus the constant square subtracted. But they're all square roots, okay? Question for you. What does this resemble?
Inverse.
This resembles some of the inverse rules that we've already covered in this class. So when you run into a square root, it doesn't automatically mean you're going to have to go into this trigonometric substitution. You first have to check if it's an inverse. If it's not an inverse, then you can go ahead and apply what we're going to learn today. Okay? Questions about that?
No.
Okay. So let's talk about the first one. How is trigonometry involved here? Okay. Do we know the Pythagorean theorem, guys? I hope so, right? The Pythagorean theorem, a squared plus b squared equals c squared, right? What we're going to do is when you're dealing with square roots in which you have numbers square added or subtracted, I'm just going to think of it and make a triangle out of that. Because if you think about it, like for example, if I make a right triangle and I have two things square added, isn't this like the hypotenuse? Agreed? And same idea, if I have something like this, couldn't this be one of the legs? And same thing for this. You guys okay with that? So that's what I'm going to do. When I'm dealing with square roots, I'm going to make a right triangle and use trigonometry to help me. So let's go ahead and check out what that means. So for the first one, so number one, for integrals involving the square root of a squared minus u squared, we're going to draw a right triangle. We're going to label that as theta. You can label it whatever you want, alpha, beta, whatever you want. I'm just going to call it theta. And I'm going to tell you the following so that this will help you. You're going to let u equal to a sine of theta. So I want you to think this through. If I'm telling you that u is equal to a sine theta, then what is sine theta equal to? U over a. Now go back to your trig days. If you draw a triangle and you know that sine is equal to u over a, tell me what is this leg? What's the length of that leg?
U.
And where does a go?
The hypotenuse.
Okay. Now, if you have that triangle, what would this leg have to be?
Squared minus u squared, the square root of b squared minus u squared.
And voila, magically what I'm talking about shows up on that triangle. You see what I'm saying? So whatever I'm trying to integrate, it's going to be one of the legs of the triangle. But very specifically, I want you to pay attention to the triangle that we drew. Anytime you're dealing with a squared minus u squared, and it's the square root of it, the opposite leg would be u, the hypotenuse would be a, and then the adjacent leg would be the square root of a squared minus u squared. Cool? Right now it's not going to make sense. Just write it down. I'll show you how to use them here in just a second. Okay. Case number 2 would be for integrals involving the square root of a squared plus u squared. Okay, now that you kind of know where I'm going with this, it's going to be a little easier for you to predict which side of the triangle this is equal to. What side of the triangle would the square root of a squared plus u squared be? Yep, our hypotenuse is going to be a squared plus u squared. Now, this is where it gets a little tricky, so you're like, okay, well, technically, one of this could be a and one of them can be u, right? So how do I know which one? Okay, always opposite of the angle would be u, and adjacent to the angle would be a. Cool? And when you're dealing with this type of problem, you want to let u equal to a tangent of theta. Because do you guys agree that the tangent of theta would be u over a, which means u would have to be a tangent theta? All right. You're going to understand why I'm making these choices once we make the problems. Because technically, I want to be honest with you. All I did is like, you can find cosine, you can find tangent, you can find secant, cosecant, cotangent of any of these triangles and kind of try to figure out the problem. But this is like the guaranteed way, I guess some kind of guidelines to make the problems easier. If you use sine when you have this type of scenario. If you use tangent when you have this type of scenario. Okay? And then the last scenario that we got, scenario number 3, would be for integrals that involve the square root of u squared minus a squared. Cool? So we're going to make another triangle. Cool? And then do you want to predict what this one looks like based on the first one? Do you think it's going to be, I mean, for sure you know that this has to be one of the legs, right?
Would A and U just be switched?
Correct. Cool. So you're going to have u right here. Think about it. That has to be u. Do you guys understand why that has to be u? If you have u squared minus a squared?
Because the U squared is acting as the
Good.
B squared.
Good. And beyond also that, John, you're actually going to want to have, instead of a being the opposite, you want that to be the adjacent. Okay? Which means this will have to be u squared minus a squared. Okay? And when you run into this type of problem, the ratio that you're interested on would be secant. So here's my question. What's the secant of this triangle? What's the secant of theta? It would be hypotenuse over adjacent, so that would be u over a, which means u would be equal to a secant of theta. Okay? So go ahead and make sure that you have all 3 rules that you can read. And that takes care of the 3 scenarios that we're going to run into. So once again, you have a scenario where you have square root of a squared minus u squared. You want to use the sine for that. When you have the square root of a squared plus u squared, you want to use the tangent for that. And when you have u squared minus a squared, you want to use secant for that. All right. Questions so far? Are we doing okay? All right, so let's do our first example here. So example number 1. Let's say we have an integral involving 1 divided by x squared times the square root of 9 minus x squared dx. Okay, so remember when I started this lesson was just because you have a square root doesn't mean you have to use trigonometric substitution, right? You first want to check every other technique we've talked about that makes that you think may be easier. So number 1 first, I would be like, is this something that you think we can solve by u substitution? And honestly, the answer to that, I don't see how u substitution would help me, because I can let u be x squared, which means the u is just 2x, which I don't really see how that helps me. If I let u be this part right here, which is 9 minus x squared, I get 2x, which once again, that doesn't help me because I have this on the denominator. So I don't really think u sub is going to work. However, when I'm looking at this problem, this is resembling a lot like what?
Inverse trig.
Inverse trig. Specifically, do you know which inverse is resembling?
Arc sine?
Not an arc sine, guys. Anyone else?
Arcsecant?
It almost looks like arcsecant. So I'm going to go ahead and go that route. I'm going to be honest with you. It almost looks like that. So let's just make sure that it's not that. Because if it is that, this is going to be a simple problem. Cool? So first, I remember that for inverse trig, I have an a squared term, and then I have a u squared term. So a squared in this case would have to be 9, and then u squared would have to be x squared, which means a is equal to 3, and u is equal to x, which means du is equal to dx. So what I'm going to do is I'm going to rewrite everything in terms of u. So that's going to give me 1 over u squared square root of a squared minus u squared du. And you should be looking at that and be like, that looks exactly the same, dude. You didn't really do anything. So here's my question. Why is this not inverse secant?
Because the term on the outside is squared.
Bingo. If this was just u, then it would have just been an arcsecant and we're done. But the fact that this is u squared, it's not arcsecant. That little power right there is the determinant of why this is not an arcsecant. Questions about that? Okay, so we investigated and we're like, okay, that didn't go well. So now, if we're dealing with a root of some number squared minus another number squared, do you remember? Well, first of all, we still need to know what a squared is. So we said a squared is 9, which means a is 3. U squared is x squared, which means u is x, right? You guys with me? We said that when we have that, we let u equal a times what? Look at your notes. When you have
Sine theta.
sine theta. So we're going to make a triangle really quick using the values that we know of. Okay, first, what is u? Well, u is x. What is a? A is 3. So that means that x is equal to 3 sine theta. Is anyone lost as to how I got this expression right here?
We're using sine because it's a squared minus u squared, right?
Correct. Square root of a squared minus u squared. All right, now use this information to tell me information about this triangle. If x is equal to 3 sine theta, that means the sine theta is equal to what?
X over 3.
Which means this is x and this is 3. Right? Opposite over hypotenuse for sine. Which means this right here is going to be what? 9 minus x squared, which is what we're interested on. Do you guys see how it shows up on our triangle? Okay. Ready? This is called trigonometric substitutions because we're going to make the use of this triangle to help us make substitutions here. Ready? For example, x squared, I can substitute it by 3 sine squared. Do you guys understand why? Did I lose anyone how x squared became, in this case, 9 sine squared? We okay? All right. Now, think this through. I'm going to have to replace this here in just a second. I'll get to that in just a second. But I'm also going to have to replace dx. Dx means that I'm going to have to take the derivative of what?
X.
Which means if I have an x expression right here, I'm going to have to take the derivative of it. So what's dx? Three cosine theta d theta. So this dx right here, guys, is going to become 3 cosine theta d theta. Are we okay with that? Anyone lost? because based on this, I'm going to make a decision of how I'm going to replace this term right here, the square root of 9 minus x squared. I want to make my problems easy, right? So I want to make this go away if possible. So because this is cosine, I want to find the cosine of this triangle. So tell me, what's the cosine of this triangle?
Square root of 9 minus x squared.
Cool. Now, remember, here's what I want to replace that, right? I want to replace the square root of 9 minus x squared. So I want to get that by itself. So that means that 3 cosine theta is equal to the square root of 9 minus x squared. Everybody okay with that? So that means that I'm going to be able to replace right in this spot right here. So let's recap. This 9 sine squared came from being x squared because x is 3 sine theta. So that's 9 sine squared. The square root of 9 minus x squared is equal to 3 cosine theta, and that's why I have a 3 cosine theta there. And lastly, dx is equal to 3 cosine theta d theta, and that's why I have 3 cosine theta d theta here. And as you can see, I have made trigonometric substitutions everywhere on this problem. Why did I consciously make this choice right here? What is it going to do to this problem?
Does it cancel in the denominator?
Exactly. That's why you always find dx first, so that you know what to replace it with, because you want to find something that's going to cancel it away. Because think about it. Couldn't I have also found like secant or cotangent or tangent? Because there's a few things that can involve this specific side, but you want to find something that's going to make your life easy. So now, think this through. Now that I have that canceled, now I have the integral of, I can pull out a 1/9, right? And that's just going to be 1 over sine squared, right? Which, I'm going to go ahead and take an extra step. What's 1 divided by sine squared?
Cosecant squared?
So I have 1/9 integral of cosecant squared d theta, and that is a very simple integral. Do we know what the integral of cosecant squared is?
Negative cotangent.
So this is going to be negative 1/9 cotangent of what?
Boy.
What? Was that Soraya? Was that you? Okay. I don't know, you guys aren't responding. But anyways, so we got negative 1/2 cotangent theta plus c, right? Anyone lost in this part? So is this our answer? Yes, no, what do you think? Like, we're just going over this for the first time. What do you think? Is that the answer or not?
Are we gonna use the triangle again to resubstitute the?
Exactly. Very good, Naomi. I mean, we made a substitution.
Mind blown.
We made a substitution, which means you got to substitute back, guys. We made a triangle. Like, let's go back. Did this problem have anything to do with trigonometry? No. We made a triangle out of that. We made substitutions based on this triangle. So when we get here, you got to substitute back into x's. So in other words, now you got to go back into this triangle and ask yourself, well, what is the cotangent of theta? Well, cotangent is going to be adjacent over opposite. So this is going to be square root of 9 minus x squared divided by x plus c. So our final answer would be negative 1/9 square root of 9 minus x squared divided by x plus c. Questions? Do you guys see now how, like, there was no trig at all, but we are purposely bringing the trig in to help us out? Okay, let's move on to our next example. Example number 2. Let's say that you have something like this. Here's the integral of 1 divided by x squared plus 1 to the power of 3 divided by 2 dx. Okay, so first, does this resemble anything we're doing today? Or in other words, is there a square root in here?
Yes.
Kind of, yeah. There's a square root in here, but here's what bothers me, that 3. That 3 is going to mess things up, right? Because that 3 means that you have a square root, but everything inside that square root is cubed, right? And none of our rules tells us what to do with cubes. So first, I'm like, okay, let's see. Can I solve this in any other way? Well, U substitution, I don't think it's going to work. Integration by parts, I really don't think how that's going to work. Trigonometric integrals, which is what we did last time. I mean, there's not even trig right here. That's not going to work. This doesn't look like one of our inverse trig, so we're going to have to get then creative about this. The only thing we know at this point is I can make this to a square root, but I have to find a way to not have that 3 inside of the root. Because if I have the 3 inside of the root, that's going to be a problem. Because none of my rules are going to work. So can you think of an algebraic thing that I can do so that I don't have x squared plus 1 to the 3/2 power? Maybe I can rewrite it in another manner. Keep in mind that I do want it to be, here's what I do want. I do want this for sure. I want this to happen. That I do want to happen. So how can I make this 3/2 power, rewrite it so that I do have a square root, but the 3 not be on the inside of the root?
Could you multiply that root by x squared plus 1?
Say that one more time.
Could you multiply that thing you have on the right half of the equation by x squared plus 1?
Oh, so like top and bottom?
No, like, so there you have x squared plus 1 to the power of 3 over 2,
Uh-huh.
which is x squared plus 1 to the power of 2 over 2 times x squared plus 1 to the power of 1 over 2.
Oh, I see what you're saying. So you're saying, okay, so you're saying I have x squared plus 1, basically to the power of 1. And then I have x squared plus 1 to the 1/2.
Yeah, so if you just multiplied the second denominator by x squared plus 1, then you would have what you're looking for, right?
You're on something, so that is an interesting thing. The problem is that I'm still going to have something multiplied by it, and I think it's going to make it a little difficult. So let me show you another little algebraic thing, and then see what you think. So that because that might be able to take us somewhere, but I'm not 100% sure. So before we go on to that route, let me show you maybe this could make it a little simpler. Remember your rules of exponents? So let's kind of put a break on this. So I'm going to break on here. Isn't this the same thing as x squared plus 1 to the 1/2 to the power of 3? Because what do you do with a power to a power?
Multiply?
So it's 1/2 to the power of 3, the same thing as 3/2. The answer should be yes. So what I'm going to do is you guys see how I'm still going to be able to achieve having a square root. Now I'm just going to have a power of 3, and then we'll see where it takes us. So Avi, I'm not 100% Abdullah, I'm sorry, I'm not 100% sure where that would take us. What I don't like is the fact that I'm going to have some other multiple. That's where I'm a little hesitant about that move. Okay? Now, I want you to take a look at the problem that you have. You're dealing with a root. What's going on inside the root? I have an x squared, and then I have an addition of a number. Based on that, if I'm going to do trigonometric substitution, what should we be thinking of? U equals what?
A tangent theta?
A tangent of theta. Which means I need to figure out what U is, and I need to figure out what A is. What is U according to this problem?
X.
And what is A?
1.
1. Does anyone not know where we got X and 1? Perfect. So now using this, we can make a triangle. Okay, if the tangent of theta is equal to X, then tell me what is opposite leg. Tangent is opposite over adjacent, so if you have X, that's the same thing as X divided by 1, guys. So this should be X, and that would be 1, right? which means that this hypotenuse would be x squared plus 1, which is what we wanted to happen. That is what we're dealing with, right? Cool. Now, look at the previous problem that we did. We're going to have to substitute things, right? So, I want you to think this through. I need to figure out what dx is. So, if I have x equaling tangent, then what is dx?
Secant squared.
Very good. Secant squared theta d theta. So, if I rewrite this problem, instead of dx, I'm going to have secant squared theta d theta, right? I have a 1 there, and then I have something to the third power. Now, I want you to think this through. I'm trying to replace this with some kind of trigonometric ratio, but I want this to my advantage. So what trigonometric ratio do I have to use to make this simpler? Secant. Again, I'm making that decision based on this. So what is the secant of this triangle?
Root x squared plus 1 over 1.
Cool, which is just that. So that means if I go back to my original problem, that is what I'm trying to replace, so that gets replaced by a secant. So now that I look at this should be relatively simple. If you have a secant square on the top and a secant cubed on the bottom, what do you have left?
1 over secant, which is cosine.
1 over secant d theta, which is cosine. What is the integral of cosine?
Sine.
Positive or negative?
Positive.
Good. So the integral would be sine theta plus c. So are we done?
No, we have to get x back in there.
Get x back in there by using the triangle. So what's the sign of that triangle?
X over root x squared plus 1.
So that means that the integral of our initial, which this was our initial problem, so the integral of 1 over x squared plus 1 to the power of 3 over 2 dx is equal to x over the square root of x squared plus 1 plus c. How can you check your answers, by the way?
The derivative of the second one.
Take the derivative and that should get you back there, but you want to trust yourself at this point, okay? But you can check your work by taking the derivative, okay? How are we doing, guys? Do you guys kind of see the point of what we're doing here? How we're using the trig to help us?
Yeah, but how do we double check again?
You would just have to take the derivative of this. If you take the derivative of this, you're going to get back that answer. So in this case, we're not going to do that because of time, but you would have to use the quotient rule here and the chain rule. But that should make sense because of the square root. I can see how you're going to get the 3/2. Cool?
Yeah, okay.
All right. Moving on to, I guess, our last example for today. Let's do a definite integral. Okay? So example 3. Let's do a definite integral between the square root of 3 and 2 of the square root of x squared minus 3 divided by x dx. Okay, first, again, just because you have square roots does not mean you have to use trig substitutions. First, check if anything else works. So question for you. The only thing that I can think of using would be u sub. If I were to use u sub, what would u have to be?
X.
Well, you never just want to let u be x, because that, all that's going to do is you're just going to change this into u squared minus 3 over u du, which doesn't do any help at all. Remember, when you're doing u substitutions, this was chapter 5, and these are the ones that you want to get very good at, you will try at least to get rid of some stuff. Because remember, you choose a u whose derivative is present. So if you do du, you can get 2x dx. But this is where you got to be careful, because some people are like, oh, I have an x there, so all I got to do is put a 2. this is not, this is, just putting a 2 there is not going to be the same thing as here. Why?
Because it's 1 over x.
Exactly, because this is not x, this is 1 over x, so will u sub work then? Can I get something whose derivative is 1 over x? And the answer to that would be no. We're not going to be able to then use u substitution. So now, I don't think it's going to be any of our other strategies, so now this is where I'm going to be, okay, maybe I'm going to attempt this by trig substitutions. So I have a square root in which I have u squared minus a squared. What substitution would I make? U equals to what? A times what?
Secant theta.
Secant theta. Okay, so let's make this, let's find out. What is u?
X.
Good. What is a?
The square root of 3.
Very good. Square root of 3. And then you have secant theta. So I think, after 2 problems, and you know what to do from this step. What do I do from this step? Take the,
Derivative of x.
okay, so what's the derivative of root 3 secant theta?
Is it root 3 secant theta tangent theta?
Very good. Cool. All right, so let's keep that in mind. And then also, based on this, let's make our triangle. All right. If x is equal to root 3 secant, then that means secant is equal to x over root 3, which means our triangle looks like what? What's our hypotenuse?
X.
Good. And our adjacent then by default would have to be root 3, which means this leg would have to be the square root of what?
X squared minus 3.
Minus 3. And once again, the part that, like, what we're dealing with will show up on our triangle. There it is. All right, so now let's make some substitutions real quick. Okay. I'm going to have an integral. What is x for us? Well, x is root 3 secant theta, right? And what is dx for us? Well, dx is root 3 secant theta tangent theta d theta, right? Now, I want you to make a decision based on what we have here. What do you notice is going to happen?
The secants are going to cancel.
And the root 3, right? And I'm just going to be left with tangent. So technically, you can choose anything you want, but if you're already in tangents, why would you choose anything else other than tangent? Do you guys see why I'm making that choice? Yes?
Yes.
So what's the tangent of this triangle?
Root x squared minus 3 over root 3.
Cool. Now remember, I'm trying to replace square root of x squared minus 3, so I have to solve for that. So that means root 3 tangent of theta is equal to square root of x squared minus 3. Yes, no, maybe. Okay, so after I clean all this up, what am I left with?
Root 3 tangent squared theta.
Root 3 tangent squared theta d theta. Now, I got a question for you guys before we continue. Remember how this was a definite integral? Do you want me to keep the 2 and 3 until the end, or are you guys going to want to rewrite this in terms of theta?
We write it in terms of theta.
Okay, are you guys okay with that then, everybody? So if you're going to do that, then that means you got to go to this statement right here. So, because these are going to be x values, right? Think about it, because you plug them in into the x, right? So that's your x values. So let's see. If I do 2, so that'll be 2 is equal to root 3 secant theta, and then I would have root 3 is equal to root 3 secant theta, right? Okay, so let's think this through. If I divide both sides by root 3, that gives me 2 root 3 over 3 is equal to secant theta. And then this would give me 1 is equal to secant theta, right? So what angle would this be? And what angle would this be? Where's secant equal, like, let's talk about the easier one. Where's secant equal to 1?
Theta equals 0.
At 0. So I'm going to use 0. Cool. 0 degrees, or actually, radians, I'm sorry, 0 radians. Okay, now where's secant equal to 2 root 3 over 3? Well, it has to be where cosine is root 3 over 2. So where's cosine root 3 over 2?
Pi over 3.
Pi over 6. Be careful.
Oh, yeah, I got it.
Cool. Now you want to use you only want to use the first quadrant or the fourth quadrant for this. You don't want to be using the third or the fourth quadrant. Remember your restrictions, because we did do an inverse here. Okay. So what that means is that instead of root 3, what am I going to use? 0. And instead of 2, what am I going to use?
Pi over 6.
Pi over 6. So 0, pi over 6. So do you guys see that by now changing this, instead of x's, now they are thetas, I don't have to make that final substitution back. Agreed? But so now the question is, how do I integrate tangent square theta? Do we know a derivative or something that has a derivative of tangent square?
No.
We don't. So then this is why I told you to cover 8.3 before covering this section. Well, if you have a tangent whose power is even and positive, you should replace it with secant square. So this one should be easy. I'm going to pull out a root 3. I'm going to have 0 to pi over 6. And this is going to become, what's tangent square theta equal to if you use the Pythagorean identity?
Secant squared minus 1.
Secant square theta minus 1 d theta. And we know how to integrate that. Because what has a derivative of secant square theta?
Tangent theta.
Cool. So this is going to be root 3 tangent theta. And then what is the integral of negative 1?
Negative x.
Negative theta in this case. You want to keep the same variable though. But you were totally right. It would be just the variable. So negative theta. And then we're going to evaluate this from 0 to pi over 6. Cool. So let's see what we got. So we got the square root of 3 on the outside. And then we got, what is the tangent of pi over 6?
Is it 1 over root 3?
Yep, root 3 over 3. Cool. And then minus theta, which would be just pi over 6, right? Minus, what's the tangent of 0? Should just be 0. Sine over cosine. And then minus theta should be 0. Okay, so that goes away. So now I'm going to multiply this in. What do we got? Root 3 times root 3 gives me 3 over 3, which gives you 1 minus root 3 pi over 6. Final answer. Notice once again, why did I not make the substitution back into x's?
Because we found where x or root 3 secant theta is equal to 2 and root 3.
Good. Basically, we switch our limits of integration into trig as well. So if I've made everything into trig, then I can go ahead and stay with just angles, and I should just be able to arrive to the final answer without having to substitute back. Okay? All right. So any questions on this problem? All right, so I'm going to go ahead and stop the recording for this. So